Parmesh, you are on mute.
You are you.
Sorry. Welcome everyone. I'm Parmesh Shah, Global Lead for Data Digital Agriculture Innovation, Agriculture and Food Global Practice of the bank, and a very warm welcome to this What's Cooking Digital Agriculture Seminar Series. And as you know, we have started a new series on AI in agriculture. This is the second webinar in that series. I'm talking the future of farming, precision agriculture, and artificial intelligence. There's huge interest on this topic. I think we got many people registered for this session, and as we know that people are very curious to know, and there's a lot of mystique around AI. And the first session webinar, we set the context of what this AI is about, what is the potential, and what is the aspects of AI there. And we had a very good set of presenters talking about that. Today, it's more about applications. How can this be applied in the real world? And we are very lucky to have very good practitioners coming in today, talking about their applications there. So the format we have is that each speaker will speak for 20 minutes each. And I would suggest that if speakers can finish between 15 to 20, because we want to get the audience in, because although we use a lot of chat questions in the audience, but we would also like some of the audience to actually raise questions and participate in, because in the new world, we would like to hear the voices more. The virtual world, we were not able to hear the participants more, but we would like to let people talk a little bit about the issues they're raising. So please keep on raising your questions in the chat as presenters are presenting, and we will pick some questions and ask you to raise your questions as well. And then we will go through one round of Q&A. We'll pick 4 or 5 major questions and then go through another round of discussion from the panelists there. So without further ado, we'll kick off the session today. Please keep your microphone muted. Please keep on asking questions in the chat. And so my great pleasure to introduce Simone Stray, co-founder and CEO of Plantix, whom I know for some time. I've been following what she's doing for some time. And it's one of the most exciting innovations to come out. And I think she's Plantix, she's going to talk more about it. And was a spin-over from Hanover University, but now it's being used worldwide in many countries. And I would like Simone to talk about Plantix now. Simone, over to you.
Okay, I couldn't unmute myself. Thank you. All right. Thanks for the kind introduction, Pramesh. My name is Simone, founder and CEO of Plantix. Greetings from India, where I am at the moment, which is our focus country. 2 words about who I am. From my background, I'm a scientist. I studied geography and soil science back in my days, and started directly into this venture out of university. So from being a researcher, becoming an entrepreneur. And I mean, when the idea of Plantix was born, we realized that we need to build a sustainable and profitable company, actually, if we really want to have an impact on agriculture. I mean, as said, we knew how science worked. We founded an NGO back in the days, and we worked with development aid organizations. But what we realized, either it's not fast enough when we talk science, or you don't get enough funding if you talk NGO, particularly for salaries, or the money flow will just stop after a period of time, right, when the project runs out. So for us, the only way was to start the venture and founding a company. That's what we did back in the days, 2015. We started with 7 founders. Now we are more than 250 employees, and on the best track record to become profitable over the next 2 to 3 years. But let's start into our key assumptions, right? So we deeply believe that small-scale farmers are the key of our global food security. And if we talk for small-scale farmers, we talk about farmers who live below the poverty line, right? But this being said, they are also able to triple their harvest, right? If they get access to the right knowledge and to the right technologies. So they cultivate more or less 2 football fields of land. They don't own machines. They learn from their fathers. However, in our days, they have a smartphone. And I remember back in the days when we started Plantix, everyone was asking, Moment, you want to help small-scale farmers? This was in 2016. Why are you developing a smartphone application? They don't have smartphones, right? But this question is not asked any longer today, because I think we all agree the rural areas and farmers are one of the most and fast growing smartphone user groups everywhere. So since we wanted to support these small-scale farmers, and we see that they have some important impact on our food security, we thought about how can we help them to resolve their pressing issues. So what do I do when my plant is ill? And this is how we came up and developed Plantix, the crop doctor, which is available on the phones. Then, since one major challenge farmers are facing are plant diseases, right? So 1/3 of harvest is lost due to pests and diseases every year. And then even thinking it further, every second remedy used to fight these pests and diseases is wrong. This means we have a farmer loss on the one side of the farmer income, but we also have a loss when we waste these remedies. So we developed Plantix and our image recognition, and with this tool we can be next to the farmer when help is needed the most. So in the end, you can imagine you are a farmer, you are standing in your field, so you see something is wrong with your plant, with Plantix, you just snap an image, and within 5 seconds, you will have an answer on your phone what's wrong with your plants. And I mean, being myself in the field, looking at these farmers, for them, it's real. You can see the glow in their eyes, because within seconds, there is some answer for their problem, right? So a lot of them are stating they feel like this is modern magic, and something magical happens in this very moment. So we work with 80 different crops and more than 600 disease patterns. And I mean, as we want to talk about AI, I want to go a little bit more into detail how we train our image recognition and how it works. So this is more or less the flow of our image, right? A user snaps an image and we get up to 100,000 images per day. In total, we now have more than 90 million images in our database. Based on this data, we train our networks and we support an accurate identification. The beauty is that with every image a farmer is sending via the crop doctor, our algorithms become better and we can adapt to what really matters on the ground, right? So the life cycle of our Plantix AI model looks in the end the following, how you can see it here. In the end, we collect data, right? Back in the days, we still had our picture hunters, we called them, out in the field, supporting us with collecting images. However, we can also harness our data fields, right? Where we have a lot of data which we can discover. And in the end, it works like this. We are getting a constant inflow in our system, right? And then we are analyzing them and we see if something strange is here. I will go into this a little deeper in the next slide. So we have the data, then our teams label them, tag them, prepare them, make them ready to go to the next team, to our ML team, so that they can start the training on these models. And then, of course, we do a lot of testing where we create test data sets and so on and so forth, making sure we really trained a robust algorithm in the end. And if this is tested, we deploy it into our Plantix app. What you see here is how our pest coverage and accuracy evolved over the last 4 years. So you can see, I said 80 crops, more than 650 different patterns, which we cover through our image recognition. Think about these patterns can also cover several crops, right? Powdery mildew, which have a certain distinct pattern. We could, or our algorithms learn how these disease pattern looks like, and doesn't matter in the end if it's a tomato, cucumber, or something else. They could recognize the pattern on the plant. And as said, now you see these jumps, and in the end, in our team, it works like this, that our internal agronomic team, I mean, they scan to the data which comes in every day, right? And we see what can be analyzed through our algorithms, and where do we see still some gaps, pictures which could not be analyzed. And these are the interesting ones then in this very moment, right? That's where they look deeper. So we look at the pictures we can't analyze, and if there is a push on the ground in this very moment, right, we see a lot of images coming in. So in the end, we train our networks on the need we see in reality and on the ground, and not on like old textbooks or list of textbooks which might have been outdated and these are not existing anymore or something. So classical example here in India was the fall armyworm, now everywhere, but a few years back it wasn't here, and we were really fast in adapting because we got a lot of images into our system which we then analyzed and integrated into our networks. And yes, indeed, we are successful with the training. So what we conduct every time here and there is also testings with people or against people. So for example, we work closely together with eCresult, who tested our image recognition with more than 8,500 images taken on 25 crops and 250 different problems. And our image recognition reached an average accuracy about above 90%. On the other side, I mean, we licensing our API also to partners who integrate the image recognition into their own systems. So what we do here and there is man versus the machine, particularly. I mean, you can imagine let's put it, more experienced, trained advisors, they doubt sometimes that machines can be better than themselves. So we do these man versus the machine tests where they get the same images as our image recognition gets. They run through the images, of course, they are much slower than ours and then our machine, and we beat them by far, right? And imagine these experts mostly are focusing only on one crop. So we did this on soybean, for example, with experts on soybean. They are solely experts for soybean. However, our image recognition covers more than 80 crops in a sense, where these experts only cover one crop. And that there is an impact of the image recognition also in real life. We were lucky that we could work with an external user research organization who interviewed 416 different randomly picked users, Plantix users, and they asked, has the amount of crops that dies decreased because of Plantix? And you can see that over 75% stated yes, thanks to Plantix, we could see a decrease in the crops which died through diseases, which is, I think, always a good point to be in the field and see if you really have impact with what you are doing. So in the end, why do we believe deeply in digital tools? I think that's the only possibility to have a scalable impact on agriculture, and that's what you can see on this map here. So every green dot is an image which we got from a farmer over the last 12 months, where we answered the problem or diagnosed the disease. And you see that India is really dark green. That's where we focus. That's where we do real marketing, where we spend money to do marketing. But the rest of the world is word of mouth. It's organic growth, what we see. By now, we have more than 35 million downloads. We got pictures from over 160 countries. And Plantix is available in 18 different languages. And yes, language is key. So among these 18 languages, 12 are already Indian languages, which we cover here. Now, this being said, what we also deeply believe in a digital tool, but also digital marketing, we do not have feet on the ground. We don't go into villages. We don't talk to farmers. Everything how we reach them is via digital marketing, means YouTube, Facebook, Instagram, and other channels. And we deeply believe in product, right? So if you do not create a product which is intuitive for the user, they will not use it. But you can't explain the product to people on the ground. This is not possible. This is not where you can get a certain scale like we see with Plantix. And let me move on. In image recognition is the one piece of our crop doctor for the farmer. However, we also realize that it's not, we can't stop there just giving a diagnosis, but we need to go further, right? The farmer itself, they need an action plan in the sense. So we widened our function flow and saying like, this is, you take an image, we give you a diagnosis as a digital doctor, but we also give you a prescription and we send you to your local pharmacy, which is the local retailer, where we make sure you get the right product, right? We are still working with chemicals here. And as said, a lot of time a farmer ends up buying the wrong product, then using it in the field. It's still toxic. It's so 3 times the problem. We do not see an impact on the plant. The farmer spends money for no impact and it harms the environment. So making sure the farmer really gets the right product at his local pharmacy, at his retailer, is one of our important features as well. Next to it, we have a community. We do disease alerts. We have crop calendars and so on. But I think the main function flow is the diagnosis and the prescription. So in the end, what we do is we support farmers and by teaming up with our local partners on the ground, the retailers, right? As said, we do not have feet on the ground. We are not there with the physical presence, but with teaming up with the local retailers, we can be somehow physical present. So we offer farmers advisory. We provide them a platform where they can check available products, services, and best prices. And in the end, we channel the demand we create on our side to the local heroes, to the retailers, and they execute in the end and serve the farmer with the product the farmer needs. Now coming to the point, how can we make sure that farmers have access to the best products. That's where we ventured even further in the value chain, saying like, okay, we are not only connected with the retailer and bring them demand, we also make sure they have the best products in their shelves. And for that, we not only have a farmer app, we also have a retailer app by now. So you can imagine it a little bit like in Swiggy, right? Where you would, or Zomato, that's here in India, the delivery services. There might be others around the globe, where you have the customer-facing app, which is our farmer app, the crop doctor, and where you have like a restaurant-facing app, which is our retailer app in the end. And these two are connected with each other. So in the retailer app, the farmer gets hot leads, gets notification when there is a farmer who needs a certain product in his region. He is able to build up their online shops through the application, and by building the online shop, uploading the products will appear on the farmer app with the prices. And we have an e-commerce platform, and then maybe some of you also asked, where does Plantix make money if they want to become profitable at some point? That's where we are making money. We sell to the retailer to make sure they have the right products in their shelves that they can sell and provide this to the farmer. So we have an e-commerce platform where we buy from suppliers and then sell further to our retailers by also, for example, providing credit lines. So this slide is a little outdated. There it still states 9 million euros generated over the past 12 months. If everything works out, we will close this year with around 18 to 20 million euros turnover revenue, what we generate through the e-commerce platform. And now, last but not least, this is my slide where I'm most proud of. As said before, we did work together with the external user researcher organization. And back in the days, and particularly when we were fundraising, a lot of people always ask me, and how can you measure your impact in the fields? And back in the days, I always answered, please give me a PhD student and I might be able to answer the question, because it's really not that easy to answer this. However, with these agency, we were able to at least measure some of our positive impact. And when we look on the environmentally side, we can proudly say that we saved over the last 12 months more than 33 million acres of crops by avoiding 2.1 million kilogram of pesticides misuse. And on the farmer side, more than 90% of farmers report an improvement of their farming practices. 80% say the amount of crops that died has decreased, which I reported back some slides. 50% reported that they even have less household expenditures, and in general 80% reported we improved the quality of life. And with this I close and say thank you for listening. That's it. Open for questions.
Thank you very much, Simone, and that's very good to see cover a wide range of things and also describe actually the AI part of it, because I think I would like every presenter to talk a little bit more about AI, because there are a lot of aspects in your approach, but today we are focused on AI and how to show that the computer images are going to be a bigger source of data than the actual data collection. The way it's done, farmers directly recording the condition of their crop and then getting converted into data training each other, and then that leading to rigor. So it's inbuilt into the model there. Thank you. Simone, there are a lot of questions in the chat. If you can just go to the chat now and start answering your questions, that would be very good. We'll take the substantive ones later on, but if you can answer the questions there. Now it's my great pleasure to bring in our next presenter, Muchiri Nyaga. Muchiri has worked for about 20 years on development, technology, innovation, and he led the inaugural cohort of Code for Kenya Fellowship in 2012, and he also was the deputy director of Open Institute Trust in Nairobi, and now he heads the local development research institute in Nairobi, and together with I think government of Kenya and others, he is really developing a national forum on harnessing data revolution for sustainable development, and he will talk to us about their experiences in Kenya on these things. So Muchiri, over to you.
Thank you so much. I hope you can hear me well.
Loud and clear. Go ahead.
Excellent. So just trying to get my my screen share to work, which it works just fine a little while ago. And then away. To be here. Thank you for the invitation. Okay, so I'm having an issue with WebEx. Now it's taken out.
Sunil, can you put Muchiri's slides from your side if he's having problems?
Yeah, thank you.
Let me try.
Yeah, as that comes up, thank you so much. It's great hearing from Plantix. Simone, you really are some ways down the path in the direction that we're going here in Kenya and possibly in sub-Saharan Africa. So delighted to have that view of your journey so far. A lot of similar aspects to our work. And on the impact side, really some of the same things that we are aiming for. I see Abbott on the chat asking saved crops and improved methods translated to increase in household income. And yes, to a certain extent it does. And that's one of the things that we've been seeing as people can have more produce coming out of their farms that can go to market than they did before, because they have the right advisory, they have the right practices, they have the right inputs. It does translate into an increase in household income, and that's been our experience from our previous work. So I'll talk a little bit about the name as much going forward, but just to give you an idea, ZD Plus is a technology platform that we developed a few years ago, working with smallholder farmers in Kenya with support from AGRA, where we built a network of village-based advisors who we now call champion farmers, who work with other farmers to help them understand and adopt their practices and find the right inputs to use. And of course, they were a very valuable part of our pathway to transfer not just knowledge but also technologies from research into farms, into actual use. So one of the things that we struggled with was how to help bridge that extensionist to farmer ratio, and part of that was this champion farmers or VBAs. They worked closely with the county government, that's subnational governments in Kenya. They worked very closely with the subnational government staff so that the ratio was a bit more manageable and they can pass on the basic agronomy and basic inputs, information on inputs, as well as pass on sample inputs that we were able to get from. But the challenge that we found was when it came to early warning information, a lot of it was extremely technical, very difficult to consume, coming from the very robust systems on the continent, but too high level at, say, a national level or a broad regional level, and not as useful to a really small administrative area. So that was the first challenge. The second, of course, was something
can I interrupt you for a minute?
Yes,
Parvati
sure.
or Sunil, can you please share the screen? Is it rocket science? And Muchiri, can you tell them when to change the slides if possible? We want to be
Sure,
as
absolutely.
helpful as possible.
I can
Sorry about
see. I can see that now. All right, excellent. Yes. So that's really where this came from. And since then, with champion farmers and working with subnational government staff, and also being farmers ourselves, growing rain-fed rice, maize, beans, vegetables. We kind of saw ways in which we can relieve the pain, and the pressure of getting things done right. So that's really where some of this came from. And now with support from JZ, we started working on an AI-driven early warning system that tries to really go down to a smaller administrative level, and be a bit more targeted and context relevant to the farmers that we're working with. So next slide, please. Pamesh, I don't know. On my end, it's still the same.
I can see there is the slide which says developing an AI for crop phenotyping.
So it's WebEx glitching on my end. So I'll just talk through, no problem, and I'll tell you to go to the next slide. So when we set out to do this, we're doing on two fronts. One, how do you do this in a way that also supports our efforts to learn better about how the different varieties are performing in the field, where we are trying to promote better inputs, especially whether it's practices or varieties of seed. So we can also track that along the way. So the idea of the phenotyping idea kind of got built into that. And this really is a broad idea of what the early warning system component of CD Plus is all about. How do you monitor the farm activities of smallholder farmers, and of course support the precision agriculture components in the areas where we're working, and then using this, really high resolution imagery and satellite data to ingest and get the intelligence that we need to provide inputs around, to provide insights around maize, beans, and indigenous vegetables for our farmers. So next slide. One of the things that we did, of course, having part of our work for a long time has been working around open data. And one of the things that we are very passionate about is how do you make sure that the data that people need to get their jobs done is available? But then also, how do we make sure that we ourselves are also opening up data? So we have data that we are using as part of this, that we're generating ourselves. Part of it is data on that's related to farm boundaries, which we're not opening up as such because that's protected data by Kenyan law. But there are derivative data sets that we're going to be making available to partners that allow you to test and see whether your model can identify a particular crop from a high resolution perspective, a high altitude perspective, which is one of the biggest challenges with altitude crop identification for smallholders, because the plot sizes are really, really small. And the other data set that we're using is this image-based data set, where we have collected images from about 800 farms of the crop development for maize, for a number of varieties. And that data set is one that it's time stamped and allows you to see how that crop has grown, and includes the contextual information around what the farmer was doing in terms of pest management, plant nutrition, etc., during the life of the crop. So some of that data is data that we're opening up as open data for use by others who are trying to build models to do similar things. And of course, the models that we're developing in our program are also going to be open and shared with others, so that we can iterate, improve, and we can all benefit from the wisdom of the collective. And the whole idea here is then to bring to the place where we can provide predictive mitigation advisory to our smallholder farmers on what then do they need to do in the areas where they are. Our technology works on using but eventually we'll have a smartphone app that will go live next year. Currently, we're heavily on WhatsApp, SMS, USSD, and of course we use ODK for our field collection work, our field data collection work, and all of that gets automatically ingested into our data infrastructure. Next slide. So yes, these are the basic three constituents are with our data, all of them looking at a different facet of our system. The smallholder farmers are very big, of course, on the advisory side and trying to advise them not just on the inputs they can get, but eventually which service provider in their locality can help them either to acquire or apply the input that has been recommended. National and county governments, because they have a deep interest in disease surveillance, the surveillance of practices, especially because that has a direct impact on productivity, but then also yield estimates, which is something that we're going to be attempting to do with some of these value chains over time. And that's data that they typically use for reporting, for food security indicators, etc. And of course, the private sector, where we will be providing them with data on commodities and commodity markets, and that's some of the data that we're hoping to monetize and will be part of our business model. The next slide. So just to give you an idea how our champion farmers fit into this, the way we've worked up until now, we're coming to the end of our second phase of our project, has really been to work with the local farmers and our network of local farmers to gather the data, not just polygons of plots, but also the photographs I mentioned earlier, the images of the actual plants as they progress through their life cycle. And then also some of the information about what services, what inputs are available in the neighborhood, which service providers, shops, etc., are then in adding those into the system. So that as part of the advisory, we're not just advising farmers that this is fall armyworm, you need to do something, but we're actually telling them, in your area, you might want to talk to, this group of service providers or this group of experts, because they might have, they would be the best place to provide you with the right inputs. Part of that is also because we have the engagements that we do as part of our network building with sector actors. So we have a Champion Farmer Academy, which is a farmer field school that runs in multiple places in the country. And through that, we know that there are people in those neighborhoods that have the skills and the information needed. That includes service providers and private sector actors of even in the financial inclusion side of things. So really, this is just a very basic breakdown of a kind of data that we collect when we are onboarding our farmers onto our system. We have a little bit of the demographic data. Some of that's what we can understand, the extent to which we have the potential to provide, to deliver impact, or for later on, trying to figure out if we did actually have some impact. One of the reasons the demographics component is really important for us is because we are trying to actively contribute to the indicators on reducing stunting and malnutrition in children under 5. So crop varieties and crop images, I've already talked about that, and those are collected in terms of routine visits, and we keep that data with us, for our research, but also part of that is what we hope to open. I forgot to say next slide. So if you can move on to the slide that starts at the top with data points collected. That'll give you a good place for us to continue. I know, Pamesh, you mentioned that you really want to hear a little bit more about the AI side of this work. So one of the things that we've done is started, of course, from the data side. Our AI needs to ingest data, right? So other than the farmer demographics, which is a fairly standard small piece of data, the farm geopoints, the boundaries, the information on varieties, the activities that are being done, and all of that is collected on a weekly basis throughout the season, and also includes audio notes from the data collectors usually in their local language, about what they are seeing on the ground that maybe couldn't be captured with the quality of smartphones that we're using for the project. Some of the technologies that we intend to use as part of this, of course, computer vision and some of the other machine learning types of AI, but also we see the potential to use natural language, NLP as part of the service delivery side, and also to analyze some of the inputs we get from farmers. There's one of the challenges that we've observed over time is that sometimes people will struggle, putting in a lot of information on WhatsApp or SMS in terms of the problem they're seeing on the ground. So giving them the option to use WhatsApp to send in an audio note would allow us to give them a bit more freedom in expressing themselves and telling us about the problems they're experiencing on their farms. So NLP becomes a really important part of that. Next slide. So just so far, how far have we gone? As of April this year, we had 40 champion farmers that we had worked with. That has now gone up, I think, closer to 60 champion farmers spread out across six counties, six subnational regions, 6 counties. They each of them had 36 weekly visits, 800 farms. Most of them are practicing intercropping, which is a really important thing to note, because as Simone and others worked in this area will tell you, if you're doing crop identification and you have mixed intercropping, it can get a little tricky for some things. And that's one of the things that we're really hoping to do a better job at learning. Next slide. We had very generous partners who've worked with, who have provided us with sample seeds, sample inputs, and we've been able to provide those. And as part of some of the interventions that we might be seeing on the ground in terms of how do you effectively intervene if crop failure is being predicted. One of the interventions that we see is usually because of failure of rain in rain-fed agriculture. So we're also tracking how many are doing any supplementary irrigation, and from what we're seeing, it's pretty small number of the farms that we have monitored over the life of the project. So far, for the pilot period, we're looking at about slightly over 10 square kilometers of crops that have been tracked. Next slide. So that part of the AI enablement for us, that was really important, especially because we were originally a very high contact, low tech organization, and we do remain fairly high contact in that sense, continue to grow our network of champion farmers. Up until 2021, we had reached almost 300,000 farmers in just 2 of those counties, and the ambition is to grow. So we really do want to maintain that level of contact, but the technology becomes a really important tool to help us become more effective and help our partners in the public sector do remain effective as well. So just looking at this map that's been on the side, those little colored spots that are blue or pink or yellow, depending on how your screen presents them, are examples of some of the farms that some of the areas where we have been. So that each of those spots is actually a cluster of farms, not just one farm. It's quite a large number of it's a cluster of quite a large number of small farms. So if you're looking at a satellite image that can only come in at a resolution of 1 square kilometer, chances are within a square kilometer would already have about 10 or 15 polygons that have been spread out across that area. So, being able to tell whether whatever is happening in one cluster is the same or different from what's happening within a different cluster, it really requires you to have a very good amount of data that's fairly high in resolution, including satellite imagery, and be able to process it really quickly. And that is something that humans really still can't do. It's too much data, too little time, and that's really where the AI comes in. So next slide. My colleagues have been working around this for a while, and the methodology for at least for the crop failure component is something like this. The identification model ingests the data, and then we work through that whole process of passing it through the algorithms And then we have an evaluation process as well, where we go through and see just how well did it do, how well is it scoring, are we getting closer to 95%, 99% on say crop identification, pest and disease identification. And then we go back and retrain the models so that we can come back and have a more accurate AI. And that's something that is a constant part of our work. And if you go to the next slide, you'll see some of our thinking around that model has also now to be to add in our yield prediction, so that our yield prediction model over time can get good enough to be a source of information for those in our space who are monitoring progress on some of these key indicators, especially around staple crops, which are very closely tied to food security. So the next slide is on our whole journey from model to advisory, and I think I talked a little bit about that, but this just shows you how we see that going. That when the AI identifies an area as having crops that are under stress, and whether it's a push or pull push or pull interaction happening between the system and the farmer, we're able to pass that as text message. And push it either to through SMS or WhatsApp, or even push it into a richer experience through the mobile app, as I mentioned before, so that whatever event has been triggered, it also includes these other linkages with local service providers, and so that whole advisory bit is kind of built into that journey. Next slide. That we have really, and we will be relying on a whole lot more. At the moment, are these. So the first group are colored. This is the data that are currently relying on, not generating at the moment, except the yield estimates. So the first, of course, is the satellite data. This is your MODIS, your I forget the other ones, but on moisture, on temperature, evaporation, all of that. Then you have satellite imagery, and then we have weather data, especially weather forecast data from a couple of sources. And then we are generating our own yield estimates, which we are now using to train our AI. A lot of this, because if you remember, we're using a very participatory model. Our data is collected by farmers who are working with other farmers in the community. We go back to those places with what the AI estimated as a yield. So at the point when the harvests begin, we go back to those areas to see the extent to which our models were accurate. A lot of things can change and do change, and we may not get on the yield estimates to a very high level of accuracy, but the accuracy for yield estimates at an administrative level will probably be a whole lot better than what currently
you may
the
have
case
to mind
across...
in 1 minute, please, because we have third speaker also. Please finish in time. Absolutely,
I'm almost done. So the yield estimates currently that many people rely on are actually eyeballing. So this is going to be a step above. The food composition tables, market level, market prices, market volumes, market prices are going to be extremely important bits of data for us, because we are, like I said, targeting the private sector with some commodity data as well, but also the nutrition information that our public sector partners hope to use. So just main challenges, next slide, really quickly, nothing new here. I think anyone who's worked in the area goes through this. If you're trying to do something that's very granular at the ground level, you need high-res data, and high-res data is expensive. So that's one of the things that we struggle with, and that affects high altitude plant recognition and all of that. A big risk for many in the global south has to do with the data governance issues. So as countries try to figure out how to work through responsible AI and try and figure out how responsible data practices look like, chances are some data pipelines will eventually either be closed off or become difficult to use. So that's something that we're seeing as a potential challenge down the line. Next slide. Of course, the opportunities that exist are also a little bit obvious to all of us, but we are looking at the performance of commodity markets as a really big issue because it affects how farmers participate in these value chains, and we are very keen on how we build smallholder resilience, not just for their own household food security, but also for trade. So that's it from me, and we're happy to provide more information, more technical information from our teams on how we're building out the AI and what it looks like as we go into public beta in about 2 months. Thank you.
Thanks a lot, Muchiri. There are some questions for you. Please look at the chat and keep on responding.
Sure.
Last but not the least, we have the last presentation by Ecologic. Asaf Dolan, the AI data analyst, specializes in AgTech and supply chain with Ecologic, decades of experience on running these kind of products and companies. And Ron Shani, who is the chairman, co-founder of Smart Group Global and owner and CEO of Ecol and Ecol and Ecologic. And they are kind of the global leaders in agriculture computing. Over to you, Asaf and Ron, and please request you to finish in time so that we have some time to take questions, please.
So, hello everybody, do you hear me?
Yeah, we can hear you.
Okay, and you can see my presentation?
We can see as well.
Okay, very good. Hello everybody, thank you for joining us. Today we will present you the Ecologic AI Digital Agriculture Platform. Here you see in our opening, we placed the 17 SDGs of UN because Ecologic is covering most of these goals. Okay, so generally today we have a lot of data, a lot of platform. Agriculture is under a huge revolution of technology, robotic, autonomous machines, AI and all images like we saw before. So there are a lot of data, and many new companies are entering to the agricultural sector. I'm coming from vast experience in farming, in management, and a part of my role was also to sell agriculture inputs and infrastructure like irrigation, greenhouses, packing houses, sorting machines. And what we faced that due to so many application data, source of information, it's very hard for the farmer to really follow up the rapid growth of the technology. Many companies are approaching farmers. He has a meteorological station, and he has irrigation controller, and he has GPS on the sprayer, and he has satellite images and drone, and sorting machine and cooling, many data that he should manage. And we see that it's a very hard task for farmers, for managers to log on to all these systems, learn them and use them. And as you said in your previous presentation, it must be very simple, intuitive for the end user to use it really. So Ecologic platform is a platform that is a very open source to other systems, and we are using partnerships with all different technologies that are using and sensing and measuring. We have developed APIs which we integrate, and we pull specific information that we need from a specific system.
Sorry, Asaf, do you have other slides or you have only one slide? Because you are only showing the first slide.
I have many.
So I thought you were stuck. Yeah.
No, I have many. No, I'm not stuck. I have many. I want to start with the concept of the ecologic, which is we have different features, but the main purpose of the ecologic is to consolidate different system to data warehouse, and then using AI algorithm, decision-making models to bring the farmer a specific insight. Do that or don't do that, and not to drill down too much to the data. The platform is using is getting a GIS GPS stamp, which is very important in agriculture. So we have place and time of each operation that is done. And when we work, we can work with individual farmers, we can work with the municipalities or with the big holding companies, and with a bigger client or holding companies which are spread on over more than one countries. We face the issue of unified language. One is working in hectare, one is working in dunam, one is using feet, one is using meter, one is using so the unit of measure is a critical issue, and in order to create one language for all, we have a very strong engine at the back of the system that knows to do the conversion and to present to each region, each country, each language with the localized data and information. We are talking about the SDGs, and one is poverty, one is zero hunger. We have done quite a few projects in the Balkan region and in Africa, where we created a big impact, helping farmers to educate the farmers and helping farmers with the know-how transfer. We are in partnership with different companies who provide us different agronomic solutions, like fertigation, irrigation and fertilizer, like spraying, like many other features that we are getting from the subcontractors, let's say, or outsource system. Now this slide here, I think it's our main target and vision, and I think this is in a way everyone's dream, to know what we are eating. Because today when you go to the supermarket, you have a package, you do not really know what is where is it coming from, what kind of inputs applied. And now we developed very strong capabilities It's with a UAE, a huge company who works in many countries. They have a vertical integration. So they, from production to the marketing, they have the whole supply chain. And they approached us to build them this kind of feature, which has a lot of advantages. So you can scan the barcode, and you will see what we get. But let me just stop 1 second the presentation. I will move to another. Where is it? Let me share screen. Sorry, 1 second. And I want to. Okay. Do you see my screen? Yeah?
Yeah.
You see? כשאני עובר, אתה רואה?
Okay. This is iPhone.
Okay. Now, when our system in any activity, any document, any screen, we can generate a barcode icon, and the barcode icon has all the information of this specific crop from day one. And if we have history, you can go even many years back. So when you scan the barcode, you get a home screen. You can see who is the farmer. Okay, we have a strong engine that gives us different scores. We have a gauge that show us, okay, we have the farmer, we have a gauge who show us farmer results comparing to other results. Ecologic is one of the few companies who is connected to Global Gap Institute and gets data, two-way data. We send data from our clients, and we get from Global Gap, we get data back, and then we can compare. We can compare and see our result comparing to 100-kilometer farmers around us from different parameters like pesticide rate, fertilizer, water, and energy. We have also, if we go to the screen, so you can see also the supply chain and how... מה? את הקודם? 1 second. רגע, אז בוא אני אעשה ככה. ואם אני עושה ככה, אז רואים?
תחזור למצגת, תרוץ על
Now you see the new one? So they didn't see the... Okay, so here I can see, you can see I have the farmers. I will show you 1 second. כן, אבל הוא קופץ לי כל הזמן. Sorry. I want to show you a different...
20 שניות לשקט.
סגרתי את זה, סגרתי אותו. סגרתי אותו. זה פסה. 1 second, sorry, I had a problem here. History. I closed the window, but I want to show you. Okay, I will go back to the presentation. If you want later, I can, if somebody is interested, I can show him in details. I, by mistake, closed the window. רואים אותי?
עכשיו, כן, רוץ על זה 20 שניות לשקט.
אוקיי. זה, לא זה. Okay, so here you can see a full traceability of the food you eat and what is applied. Next slide. No such thing. מה?
דבר.
I'm trying to share it again, but I have a problem. Let me share it. I'm opening. אתם רואים את זה עכשיו?
נלך לסוף.
You can see my screen?
בואו נלך לסוף. לך לסוף,
רואים?
לשקף האחרון.
רואים אותי?
כן.
זז? אני בשקף טוב או לא זז?
לא. לך תעשה מסך מלא ולך לסוף.
I'm sorry, I tried to show you the traceability issue on a different... Now you can see my screen, right?
Yeah.
Okay. You know why זה? הוא לא מצליח להזיז לי את ה... רואים אותי? If we are talking about AI capabilities, we are following many parameters, and we have a lot of thresholds that can raise once we see parameters that are not correct, as a water parameter, soil parameter. We can measure also before harvesting. We have models to decide when to harvest grapes for wine and when is the best sugar development. Of course, we have very powerful tools of reports who can generate. And if I will talk about some success story that we did, we have, as I said, few projects in Balkan that we did with the World Bank and the UN to improve the individual farmer. Sri Lanka, it is more a statistical collection of data for the government. If we are talking about the environment, due to that we have a lot of data, we can certify farmers and provide them a credit carbon certificate, and in that way, of course, we reduce carbon footprint, and we are also able to provide farmers some income from different channels. This is, for example, measuring that we did in Austria, near Vienna. We can see the carbon footprint, very strong BI algorithm and AI, which is running on the data warehouse, bring us back statistics, brings us back costs, profits, use of energy, use of water, use of fertilizer. And the strongest thing is that at the end you are getting a dashboard with all main parameters. So in a one glance you are getting many systems, data, thresholds, which of course are reaching by email, by WhatsApp, by SMS, according to the preset of the system. I didn't talk about growing protocols, that we have a vast library of growing protocols. On growing protocols, we have models and AI which control and do correction to localized regions. So we see a very good trend of improving. And Ecologic is chosen by Microsoft to lead the agriculture vertical from the aspects of the ECS cloud. Microsoft built a huge database on different industries, different verticals, in order to compensate the carbon footprint that they do. And Ecologic is chosen to collect, to deal, and to provide to the ECS cloud all the agriculture practices. Thank you very much. If you have a question, you can also scan the barcode here, and we will get back to you very soon.
Thank you very much, Asaf and Ronnie. And I apologize to the participants that we're not keeping in time. So I think we have to take some questions here. And I think the three presentations are interesting. They bring different aspects of it. So what we have done is that we'll pick some questions from the chat. And so let me take first a question for Ecologic. From what you presented, there are many applications there. A typical World Bank project, when it wants to apply this AI, it looks very complex. So can you define, if we are increasing market access for farmers, how would your solution be used in that particular project when we are working with smallholders?
I can give you an example for where was it? Nigeria? In Nigeria, we received a region of almost 100,000 individual small farmers, and this is a region that wanted to be developed. So again and again, they failed to provide healthy and sustainable agriculture. What we did, we placed all the polygons and all the farmers on the GIS layer, and we controlled the farmer agriculture practices. We follow it in a different ways. So instead of giving money to the farmers to buy inputs, we have supplied the inputs, but we supplied it based on machine learning and image analyzing. So we did not give farmers additional materials if we didn't see emerging of seeds coming from the field. So we followed the field with the satellites and saw the progress of development. And according to milestones that we put prior to the project, we released the inputs. So the farmer received here two things. One, very good education and knowledge transfer by our agronomist going around. And second, we were very efficient in the product and inputs that we spread around, because we had a very, very good control. And it was a very successful project.
So who is your client, Asaf? Are you directly doing this, or you're doing through that, because it looks like it requires a lot of your presence there. And as Simone says, she has no field presence. She just uses the AI algorithm and delivers all the services. Do you have to be there to do this, or does AI remove the need? And see, we have Muchiri's model, which is a very high touch still model and uses AI plus high touch. You have, so can you describe that? Who are you doing this Nigeria work for?
Yeah, we always do it with a local partner. When Asaf say we transfer agriculture, it's transfer the know-how. Okay, so it can be student or what we call in people that come into the field. Everyone have one or two field or village. Okay, they collect the data. Up of it, we collect automatically by satellite, by other device that we put it in the field. We collect the data. But when you have the data and you see one picture of all the farmer that work in the region, we can start to analyze it, okay, automatically, because we know what is the retailer want and when they want it, okay, and we can automatically by our student that go into the farm prepare the farmer for the needs, okay? And we can know, because we have the all information, the center that collect the information can support farmer. You know, if you see one farmer that they have a plant protection problem and one farmer don't know how to use fertilizer, immediately the system send an alert and tell to the field officer, the student in the farm, see, this farmer needs support on that parameter. Okay, so all the working to support farmer going to be very, very successful and easy, because in the back office the system all the time collect alert, manage it, and bring what we call in DSS, decision support system, to the personally farmer.
Usually we do it with localized cooling facilities or logistic centers. So we are reaching to a lot of farmers, but we are doing it with hubs that are in the center of our farming area.
Thank you. Very good, very good. So Muchiri, the question for you, which people are asking is, how do we scale up? What are the challenges in scaling a participatory approach, and do you think AI can facilitate taking the participatory approach to scale?
Thank you for that question. And absolutely, it's so for us that's something we're exploring now. I think the scaling up right now, our scaling up is very high touch. Like I said, and one of the things that we have seen as an opportunity is to use the AI and the system to reach out and recruit new champion farmers without necessarily having to bring them into a room. So we see an opportunity there to use digital tools, digital platforms to do that. Can AI do that? Absolutely. AI can support that. We are especially seeing an opportunity there around NLP and platforms that that utilize chat, for instance, as one way of creating points of interaction between our farmers as we try to scale beyond what our resources would allow if we had to do it a farmer at a time. So there are big opportunities there, but content and creating interesting interactions, joyful ones, through the systems is key, absolutely key.
And Simon, the question for you is that we have a large investments in India. How do Plantix and the World Bank investments work together? Do you have any suggestions?
I thought you will tell me this one, Pavesh. Look, I think we are always happy to work together with partners, and I think there are new projects on the horizon, and I mean, it's not necessarily only on scalability of the product, but we are deeply interested in financial products for our users, for example, so for the retailer or the farmer, right? Credit is one major point in agriculture. I think there is new topic on the horizon everyone is looking into, which are carbon credits. There are different insurances, so there are different topics where we would not necessarily say like it is directly connected to our AI and image recognition. However, what we have managed to create is really a channel to the farmer in a sense, and yeah, a digital channel where we can reach out to a lot of farmers at the same time, which might be interesting for certain partners to use these channels, and where we always see a good synergy when we can provide benefit to the user and at the same point, right? And that's a deep learning what we created over the time. You will only get high engagement with the user, high adoption of technology if you create a product which adds value to the user, which solves a certain pain point of the user. Otherwise, there is no need for a farmer or user to use your product. So only if you can manage that, you will be able to scale, and you will be able to create a certain trust, engagement, adoption of your technology.
So a related question is that if you look at the leaves and all, are you seeing other applications of computer imaging, images, analytics, whether it's on the fertilizer application or biofertilizer or any kind of other products apart from the pest detection part of it?
You mean within our app or
I'm saying that since you're already in that field,
Yeah.
are you seeing other applications based on computer imaging being developed?
I think so. On the ornamental side of things, ornamental plants and mapping out plants, there are a lot of good initiatives around, right? So plant, I'm not good, nature AI or something it's called. There are several crowdsourced projects which are really doing a great and amazing job in analyzing all the plant flora out there. When it comes to diseases, we have not seen real competition yet. I mean, we are growing our database. There are some having really reduced data sets and maybe also different specific use cases. Let's focusing on tomato, understanding when a tomato is really ready to harvest, for example. This is not our field of excellence, right? There are other companies out there doing much better jobs using robots for harvesting and so on and so forth. So I think on these wide range, we are still having the lead. However, I will not say there are others being much better in more narrow specific fields. And then if we would venture into weed detection, it's always somehow in the backlog on the roadmap saying like this might be something. Till now we have not done it. But yeah, maybe it will come. But I think otherwise we stick to our zone of excellence, plant diseases and pests. So that's where we are good in.
Thank you very much. Thank you very much. So I think we're coming to the end of it because we're losing people now. So thank you very much for everyone today, all the panelists who really gave us their valuable time, and all the people who participated and asked very useful questions. We continue this series, and please be in touch. The third in series, we are going to discuss generative AI now, and what are the generative AI applications which are coming in agriculture, and it will have the AI chatbots and all what are being used in many countries all over the world. We'll discuss them, applications there. So you'll have Microsoft and Google and Digital Green talking about their applications in the next webinar. I also would sort of come back to all of you to discuss the possibilities of collaborating with various World Bank programs as we go forward, because we have got a better idea of what you have to offer. And so we will try to do some matchmaking in the subsequent conversations with you. And thank you very much for your time. And thank you everyone for joining us. Good morning, good afternoon, good evening, wherever you are. Bye-bye.
Thank you.
Bye-bye.
Bye.
Thank you, Pamesh. Thank you, team.
Thank you, Ronnie. Thank you, Asaf. Thank you, Muchiri. Thank you, Simone. Bye-bye.
מה דני, אתה איתנו? אתה איתנו?